Very good afternoon, everyone. A very good afternoon and welcome to today's Unit 1 class. I hope all of you are keeping fine, doing good. Guys, girls, all of you all, we are in topic 2. We are still in part 1 of topic 2. Things have been going quite slowly because there is quite a lot to learn over here. Okay, so guys, girls, before we move forward, guys, let's quickly recap what we have been learning so far. Okay, so we have been extensively talking about networks. Okay. So everybody, when it comes to a network, we first spoke about how data flows in a network. How does data travel in a network? Data is always broken into packets. Okay. Whenever you transfer a file, that particular file is broken into packets. And that packet diagram is a very big diagram. We'll be drawing it later on, very much later. But for now, tell me the parts you remember. You have the payload in the middle. You have the header and you have your trailer. So every data packet has a header, a payload and a trailer. Now go a little bit more into detail and tell me what would you expect to see inside the header? Sender's IP address, receiver's IP address. What else? This side, so far she's answering everything now. In the header, you would see the sender's IP address and receiver's IP address. Further, what else would you see? The MAC address, right? You would also see MAC address, sender's MAC address, receiver's MAC address. Then guys, girls, MAC address belongs to which part of your computer? The network interface card, right? The network interface card contains your MAC address. Everybody okay with this? Right. Guys, girls, if you were to create a network, and say, for example, you have a bunch of desktop computers and you want to connect all these desktops together, what is your go-to network component? You want to connect wired devices in a network together, not a hub. You want to connect wired devices together. You want these devices to communicate with each other. You would go for a network switch, isn't it? A network switch allows you to connect wired devices. You could use a hub. What is the problem with a hub? Inefficiency, since it? Exactly. A hub forwards everything it receives to all connected devices, which is going to cause a lot of congestions in your network. Okay. So hub is not the best. Okay. A switch contains a table. The table was known as what? Your MAC addressing table, right? And in that table, what would you find? We had a table where it mentions the port number and the MAC address of the device that is connected to that particular port. Everybody okay with this? Then guys, if you wanted to send data to many connected devices, the same data needs to go to many connected devices. Like she said, you would go for a hub. Then guys, girls, if you wanted to connect to different networks, what is your best go-to option? You would use a gateway. But in most cases, who behaves as your gateway? A router, isn't it? Your router behaves as your gateway. Now, when a router is dealing with data packets, now boys, a switch, when a switch receives data packets, what does it inspect? No, MAC addresses. We said MAC address table. No, when a switch receives data packets, it inspects the MAC address and then sends it to the relevant port. A router inspects IP address. A router inspects the IP address and sends it to the relevant device. Everybody okay with this? A router is also able to convert analog signals into a form that computers can understand, which is ones and zeros. What do we call that form? Not binary. It's binary, but what do we call it? Analog to digital. So which part of the router is responsible for converting analog signals to digital? Modem. We have something called a modem built into the router, which is responsible for converting analog to digital. Okay. Then guys, girls, sometimes we have a problem where Wi-Fi signals or wireless signals are not reaching specific parts of your house. What is the device you could then use? Or certain parts of your house, a Wi-Fi signal is extremely poor. Repeater, booster, extender, any of these devices can be used. Do we only use these devices for wireless devices? You can also use them in wired, right? Even wired connections, every 100 meters, there is a small drop in quality. So if you have a cable running for 100, 200 kilometers, the quality is going to come down to 0. So in between, in various places, you will put repeaters. Are we all okay with this? Then guys, I took up the example of a hotel. A hotel has people living in rooms, and they have all hotels, a basic facility hotels provide is we provide you with Wi-Fi. Now, when you go to a hotel room, they don't give a router per room. They don't. Is it clear? They have one Wi-Fi connection. All the guests have to connect to it. No matter which part of the hotel you go to, the Wi-Fi network is there for you. Now, how do they spread out this Wi-Fi network across the entire hotel? By using something called wireless access points. Wireless access points are connected to a variety of routers. These access points are placed in various parts of the hotel. So as you go from different parts of the hotel, you don't see it, but you're being switched from access point to access point. You don't see it happening, but okay, you might notice in certain places signal is very good, certain places signal is low. Is it clear? But actually what's happening in the background, you're being switched from access point to access point, you're being switched. Are we all okay with this? Okay. My final question to you all, you don't have it, I can take it from here. My final question to you all, what does a server do? A server is also a part of a network. Not every network will have a server. Many networks will have a server. Any words you can tell me about a server? Stores data, excellent. Very good. What did you say? Handles requests, yes. Handle requests from clients. A server is basically handling requests from clients. Okay, can I say it's a very powerful computer? It is a very powerful computer. Can it deal with multiple clients at the same time? That also, yes, it can deal with multiple clients at the same time. Are we all good? Okay, so we also saw server computers, right? Now everybody, let's continue from where we stopped. Boys, behind all of you all. Where we stopped at last time was over here. We went through all this server, right? Network design and implementation. Boys, are you all with me? Okay. So guys, girls, everybody, students online, I hope you'll have the tute. If you all don't have the tute, you all need to be telling me. Okay, how do we design a network? Okay, right. It's a very complex thing. Okay, right. So primarily, guys, you have two connection mediums. Okay, you can either use a wired connectivity or you can use wireless connectivity here. Each has its own advantages, disadvantages. Okay, some work well in certain situations, some do not work well in those situations. Okay, right. Can you guys see the types of wired options we have? We will be going through them one by one now. We have something known as a twisted pair cable, something called coaxial cable, fiber optic cable, power line. Okay, then under wireless, what are our options? We have these waves called microwave, radio waves, light waves, satellites. Okay, these are what we are going to go through right now. All right, can everyone come down to twisted pair cable? We are going to spend some time over there. Can everyone open that up? A twisted pair cable is a type of copper cable. Everybody okay with this? Okay, that has two copper wires inside it. Each copper wire has an insulated layer. You all read it and look at my screen when I tell you all to look. So everybody, this is what we call a twisted pair cable, and I'm sure many of you all have seen these cables. If you were to open this casing, you can see there is an insulation there now, because copper conducts electricity, right? So if it was pure copper, you guys are going to get electrocuted when you touch the cable. So these cables are insulated with material where it prevents the current from touching you. Everybody okay with this? Right. And if you were to open up this clip, can you all see there are some plastic clips over here? These plastic clips are used to connect the cable to your network interface card or connect it to a switch. Everybody okay with this? If you were to pluck out these plastic clips, this is what you would see inside. Everyone saw? Don't worry about this STP and UTP. I'll tell you all in a minute what they mean. Okay? If you were to pluck out these clips, this is what you will see. Can you all see that the cables are twisted? Everyone saw the cables are twisted. And can you all see inside? You all have your copper. Everyone saw the copper? Right. Guys, in a building, in a house, electricity needs to flow to your light and your fan and your AC and all that now. what do we use inside those wires? If you take, for example, a microwave has a wire that's connected to your plug. What is inside that wire? What material is used? Copper. Everybody okay with this? Do you all agree with me on this? Even for electricity purposes, we use copper cables. Okay. For data transfer purposes also, we are using copper cables. So listen to my wording carefully. Does that mean in a network, when I use a twisted pair cable, data is flowing in the form of electrical signals? What did I tell you all? At home, for our devices, we use a wire. If you open up that wire, it is copper cable. And we know for sure inside that wire, electricity is only flowing. We use the same copper to connect networks also. Okay, like for example, the twisted pair cable. If you open up a twisted pair cable also, you will find copper cables inside it. Okay, so pretty much same cables we are using. Electrical cables are not twisted, network cables are twisted. But both are using copper. So can I say something like this? In a network that twisted pair cables are used, data flows in the form of electrical signals. I can say that, right? Because copper, what does copper transmit? Electricity here. In a network, what does it transmit? Electrical signals. Are we all okay with this? Boy, is it all of you all with me? You seem to be somewhere else. Okay? Come on, get your mind over here. In a network cable, in a twisted pair cable, we use copper, right? Inside this copper, electricity is flowing, but it's carrying data. It's carrying electrical data. You don't say electrical data, you say electrical signals. Okay? Right. Everybody, can you all keep reading it now? Keep reading it. A twisted pair cable can be unshielded or shielded. So shielded basically means what? An extra layer of protection. There is an extra layer of protection. Okay? Right. Can you guys look at this? Look at this diagram, guys. This particular cable has an extra layer of protection, which we call shielding. This one does not have that extra layer of protection. Now, everybody, in this room, my Wi-Fi router is not the only wireless device. Agree? In this room, all of you all are having smartphones. Each of you all are having a SIM card. Wireless signals are coming to your SIM card, isn't it? So there are a lot of wireless signals in this room. Everyone agree with me? Your wireless signals will interfere with my wireless signals and reduce the quality of my wireless signals. Agree with me? Your wireless signals that are supposed to be coming to your smartphone will collide with wireless signals that are supposed to be coming to my router. And that collision reduces what? Reduces the quality of my signal. So the speed may reduce for me. Everybody okay with this? But in a cabled connection, the problem of interference, you know what interference is now, right? Everybody? You all now know what interference is. Now, interference is what? When other wireless signals come and bother your signals. Is it clear? But in a wired connection, interference is minimized a lot because the cables are the wires are inside a cable now. In wired connections, interference is heavily minimized. But guys, sometimes you want to minimize it even further. Then what do? You go for shielded, twisted pair cable. Everybody okay with this? When you want to bring down interference to its minimum level using a wired connection, it's recommended to go for shielded. Sometimes, guys, your cables are running outdoors. Okay, sometimes your network cables are running outside the building. Then you have a problem of what? You have a problem of insects biting on these cables, isn't it? When insects bite on this cable, there's a chance when it rains, water might seep into these cables, destroy your cables. So sometimes for outdoor purposes, you will go for shielded twisted pair cable. For indoor purposes, you will go with unshielded twisted pair cable. Are we all okay with this? Guys, girls, all of you are okay? Right. So now you all know one type of wired connection, which is twisted pair cable. And generally in school, computer labs, and at home, for any wired connectivity, you all are mostly using twisted pair cables. Twisted pair cables are made up of what? Inside, what do you have? Inside, you have copper. Twisted pair cables can be of two types. It can be shielded, generally for outdoor purposes, and for indoor, we use unshielded. Are we all okay with this? One more thing, guys. Twisted pair cables have so many versions. Okay, can you all write that with me? Twisted pair cables has so many versions. They have kept getting better and better and better and better. So everybody, for example, we have Cat 5. I'm going to put a note over here. Cat5. Everyone know what CAT stands for? What does CAT stand for? CAT means category 5. As an acronym, we say CAT. We have Cat5, we have Cat6, we have Cat7. Everybody, from version to version, what do you think got better? From Cat5 to Cat6, what would have got better? The speed or the bandwidth. From version to version, the bandwidth kept getting better. Okay? Bandwidth got better in every version. Are we all good? In every version, the bandwidth got better. Okay. Now we have seen twisted pair cables. We are going to have a look at another network cable which is also using copper, but its structure is a bit different. You don't have a clip. You have a pin at the end of it. Okay. So everybody, can you come down to, sorry, can you go through the characteristics of twisted pair cables, everybody? Characteristics of twisted pair cables. So agree with the first point. They are copper. So what do they transmit? They basically transmit electricity. In a network, you will say electrical signals. What is their bandwidth? Maximum up to 10 gigabits per second. Up to 10 gigabits per second. Cheap to manufacture. Hence, it's commonly used. Okay, because it's cheap to manufacture. However, they can, even though they are wired, they can suffer from electromagnetic interference. What was your solution for that? Use shielded twisted pair cable. They are very easy to install because you can bend them, you can purchase them easily, they can be rolled up. Okay, you don't have all those problems. So easy to install. Where do we normally use them? Telephone connection, Ethernet connections to create a local area network. We use twisted pair cables. Okay. Can we move down to the next one? Coaxial cable. When you look at coaxial cable, guys, again, similar word, is a type of copper cable. Keep reading it. It has a central copper wire that has an insulated layer, a metal conductor, and a protective plug. Very similar to twisted pair. But the clip is going to be different. Everyone, look at my screen. Look at my screen. This is what we call a coaxial cable. Where do you think we use these? Very good. CCTV, antenna. This is where we use it. Okay. Right. If you look at the structure, guys, again, look at the structure. If you were to open it up, this is copper. This is also, there's a shield outside it. Insulation is outside. Okay. Again, a copper cable basically. But this one we call coaxial. Okay. Right. Can we go through its characteristics, guys? So normally for network, we don't use it. We use it for connecting to TV channels, for connecting CCTV cameras. Okay. Okay. Can you guys read it? They transmit data using radio frequency signals. Hence, we use it as an antenna. They can transmit data up to 10 megabits per second. So the difference between twisted pair and coaxial, major difference. Keep reading. They are cheap to manufacture, but not as cheap as twisted pair. They are less prone to electromagnetic interference because of their metal conducting layer. They are difficult to install as they can be stiff and difficult to bend. Everybody, this area over here is difficult to bend. Okay, so bending the cable, you can bend actually, but it doesn't have the flexibility of a twisted pair cable. Twisted pair cables has proper flexibility. They are mainly used in cable TV connections and sometimes interconnection. Of course, I can't give you all examples, but like he said, CCTV cameras, we do use them. Okay. Shall we move on to the third type then? Everybody, what are we talking about right now? Creating a network, right? What were your two mediums? You had wired and wireless. Under wired, we went through twisted pair, we went through coaxial. Both of these are copper cables. Now we move on to the third one. Okay, boys? Now we come on to something called fiber optic. The cable is called fiber optic. What does it use? A fiber optic cable has many thin strands of glass or plastic that make up the core of the cable. Okay, sounds interesting. The core is covered by a cladding, which is covered by a plastic coating. This plastic coating is covered by, sounds very confusing. Let's look at the diagram. Okay, everyone, you already by heart how it is. Okay, as long as you all know it uses glass inside it, that's good enough. Everyone, this is what we call a fiber optic cable. Okay, this is what a fiber optic cable looks like. Look at the clip, guys. The clip is very different. If you were to open up the cable, guys, this is what you would find inside here. The glass cladding we were talking about. So fiber optic cable, guys, it doesn't transmit electrical signals. It transmits light waves. It transmits data in the form of light. Everybody okay with this? And guys, do you all know what is the fastest? Which one is faster, sound or light? Light travels a lot faster than sound. Is it clear? So when you use this cable, guys, transmitting of data happens at a very high speed. Is it happening in Sri Lanka? In Sri Lanka right now, SLT is providing fiber optic connections. But do you all know this? Fiber optic connection from SLT to your router. Okay, but then from your router to your laptop, you all are using what? So you all have a fiber optic connection from SLT to the router. But then from your router to your laptop, you all are using Wi-Fi, or maybe you all are using a twisted pair cable. So there is a big drop in bandwidth. Fiber optic operates at a very high speed, but then Wi-Fi and twisted pair do not support that speed. You get it? So data comes at a really fast speed to your router, but then from your router to your laptop, from your router to your smartphone, the speed reduces a lot because you're using Wi-Fi. You get it? Between you and the router, there are so many physical obstacles, interference, distance, all those problems are there. Okay. All right. Can you guys read fiber optic? They transmit data using light. The previous two was transmitting data as electrical signals. This is transmitting using light. They can transmit data of up to 1 gigabit per second. Okay. They are extremely expensive to manufacture. They are not prone to electromagnetic interference. They transmit data in the form of light now. So electromagnetic interference is not a problem for them. They are difficult to install. Guys, when you call up SLT and ask for an internet connection, you can ask for ADSL connection or fiber optic connection. ADSL connection means what? They will install the connection using twisted pair cable. So ADSL, they are ready to install. Fiber optic, what do they tell you? They will tell you, can you go out and find the nearest SLT telephone pole? And they'll tell you to read the code on that pole. When you read that code, they put it in their system and they see whether fiber optic is available in that area. You get it? Because still fiber optic is not available everywhere in Sri Lanka, certain parts only. So when you call up SLT and say, I want a fiber optic connection, they will tell us where you are located. Then they will tell you, go outside and find the closest SLT telephone pole. And they'll tell you to read that number there. When you read that number, when they enter into their system, then they can see whether fiber optic is available in your area or not. Everyone okay with this? And as I know, guys, twisted pair connection, which we call ADSL connection, it's about setup cost is I think 5,000-6,000 rupees only. When you go for fiber optic, it's 23,000 rupees if I'm not mistaken. Okay, a bit higher. Okay, can you guys read the last sentences? Last sentence. They are often used for internet connection and transmitting data over long distances. Everybody okay with this? Now, guys, I want to show you a video on how this entire world is connected. Okay, it's a graphical video. Okay, can you guys just check it out? So everyone check this out. One by one, there are some stats. I want to pause and I want you to read that. Everyone, can you all listen to this? Now, guys, something confusing about to come up. Can you guys read the next one? Powerline. We have something called Powerline. Okay. Is a type of connection that is created using adapters that are plugged into your electrical plug sockets. You all know what are plug sockets now? You all have plugs over here now. You connect adapters to those plug sockets and you can create a network. Interesting. Let's see how this works. When a power line adapter is plugged into a socket, it transmits data over the electrical wiring. You understood this? In power line, you're using your building's existing electrical supply to transmit data. Everybody okay with this? In power line, you're using your building's electrical supply to transmit data. We'll see how this works. So everybody, check out this video here. Okay, so where is it?
Hello, everyone.
Right, can you guys read the characteristics of power line connections? They transmit data using your existing electrical wiring. They can transmit data at speeds up to 2 Gbps. That's even faster than fiber optic, right? But nobody's using it because of it's not expensive. We spoke about it just now. It can transmit up to 2 Gbps, but it's going to be heavily affected by interference. So then the speed drops a lot. You get it? Okay. They are relatively expensive to manufacture. That's not, I took this in the textbook. It's not a very, you can buy these adapters, not too expensive. But they are prone to electromagnetic interference and are limited by the condition of the electrical wire in the building. Okay. They are very easy to install. You just plug in these adapters into your plug sockets. They are often used in large houses and buildings to allow data travel more effectively over a long distance. They can also be used to extend your internet connection to a part of your house where coverage is poor. Everybody okay with this? So now we have spoken about what? We went through under wired connections. We went through twisted pair, coaxial, fiber optic, and now we came down to power line. Now from these four, which three are very similar? Or which one is the odd one out? Twisted pair uses copper cables. Coaxial uses copper cables. Power line also uses copper cable. The odd one out is fiber optic. Only fiber optic is using light waves. Are we okay with this? Okay. We have one more option. Sorry, my bad. We don't have one more option. We now move on to wireless. My bad. I had something else in mind. We now move on to wireless. Now, guys, girls, before we move on to wireless, I need to explain something to you all. Everybody, there are a lot of wireless waves flowing around us. Okay, everybody, you can't see them, but they exist. Wireless waves. Okay, can you guys look at this diagram over here? Look at this diagram over here. I was supposed to show you all this video also. Power line being used in real life. Check it out. Well, in some of these adapters. Okay, right. Then, guys, girls, I told you about these wireless waves around us now. These wireless waves of different types, different sizes. Okay, right. So we call it what? We call it the electromagnetic spectrum. Okay, a little bit of physics now, but you all need to understand this to understand wireless connections. So, guys, can you all come from the right hand side? Right hand side, yeah. Everyone look from the right hand side. You have radio waves, microwaves, infrared waves, visible waves. And to make it easier for you all to understand, they have given you an example of how big it is. So from the right hand side, you can see from right to left, the size of your wave, which we call wavelength, it's getting bigger or smaller when you come from right to left. It's getting smaller, right? At the beginning, radio waves are the size of a building. Then when you come to microwaves, they are the size of a human. infrared wave size of a bee. Then it becomes size of a, what do you call, pinpoint, very tiny. Then protozoans, you can't even see it. Okay, molecule, it becomes really, really tiny. I mean, these waves also you can't see, but they're as big as the size of a building. None of these waves you can see. They are all invisible, but we're talking about their size, their wavelength, okay, from big to small. Now, everybody, obviously, when something goes from big to small, what about its speed? Speed also goes same direction, or speed goes the other way? When something goes from big to small in terms of size, its speed will go proportionally or improportionally? Inversely proportional, sorry. It increases, right? Speed will go the other way, isn't it? So guys, can you all see over here, we have something called frequency. Frequency is basically something to do with speed. Okay, so when the wavelength gets smaller, the frequency gets bigger. Frequency gets bigger means what? It can travel faster. Are we all okay with this? It can travel faster. Are we all good? Okay, so just keep this in mind. Can you all go through this diagram again? You have radio waves, microwaves, infrared, visible light. For network purposes, guys, we will be stopping at visible light. In medical purposes, X-rays, gamma rays, and all that is used. But for IT purposes, in terms of a network, we stop at visible light. Okay, sounds good, right? So now we are going to learn how can we, now these waves are all over the place now. So why don't we use these waves to transmit data? Why stick to cables? Cables is not portable now. If you use a cable, you're stuck to that place. You can't move around. But if you go for wireless waves, if you go for these electromagnetic waves, you get a lot of portability, isn't it? Okay, and it's not so messy, no tripping hazards. Okay, so let's see how this works. Okay, so everybody, number one, we are going to deal with microwaves. What do you know about microwaves? What do you know about microwaves? Everybody, look at this diagram and tell me. Higher frequency than radio waves. Agree? So what does that higher frequency mean? It can travel faster. You can also say this. It can carry more instructions than radio waves. Are we okay with this? You can say it can travel faster. You can also say it can carry more instructions than radio waves. Okay? Right. Excellent. Now let's see how this works. So everybody, can you come down to microwaves? We are going to talk about microwaves now. So microwaves are electromagnetic waves. I showed you. Microwaves are a part of this electromagnetic spectrum, which can be used to create a wireless connection. The problem with microwaves are point to point. What does that mean? Microwaves are the size are like human size now. They can't go through solid objects. You get it? Microwaves are not powerful enough, or rather are not big enough to go through physical objects. Okay, which is why if you're communicating using microwaves, sender and receiver need to be directly facing each other. You can't have obstacles in the middle. The waves will not transmit properly. Everyone okay with this? For microwave communication, sender receiver must be directly facing each other, which we call what? Point to point, which means they can only travel in a straight line from one technology to another, from one sender to a receiver. Okay, microwaves are high frequency waves. High as in higher than whom? Radio waves, higher than radio waves. Okay, so because they have a short wavelength, what happens? They can travel over, everybody, because of their short wavelength. They are smaller than radio waves now. So what do we say over here? Short distance. Okay, and they have to be point to point. Everybody okay with this? So where do we use microwaves? The last paragraph tells you that. Microwaves are used for what? Communication between towers. What towers are we talking about? We will see shortly. Okay. So everybody, guys, girls, all of y'all, look here. When you, let's say you're using dialogue below. Let's say you're using dialogue and you're on a phone call with somebody. When you speak, guys, your voice can be immediately heard by the other person. The other person can be in a different part of the world. Okay, so let's say we have somebody in Kohuala talking to somebody in Vellavata, quite a distance. Now, how does signals from Kohuala travel all the way to Vellavata? Have all of you all seen towers like this? Everybody, have you all seen towers like this? In various parts. Tell me, typically, where would you see them? Typically, where do you see these towers? Especially in Colombo, you don't get mountains and all to see it. In Colombo, normally, where do we see it? What did you say? On top of buildings, right? Normally, you see these signal towers on top of buildings. So normally apartments, they would rent out their rooftop to Dialog, SLT, to come and put their signal towers over there. Now here also right now in this area, Platinum is the tallest building. So Platinum doesn't own this building. The owner of this building has rented out the roof for, I don't know who the ISP is there. I think it's SLT. SLT has come and put their signal towers on the rooftop. Is it clear? So why do we use these signal towers? To transmit signals. So guys, when you make a phone call, guys, your signals, now when you speak on your phone, your wireless signals will go to the closest signal tower. That signal tower will take these signals, amplify them, strengthen them, and send them to the next signal tower. The next signal tower takes it, strengthens it, amplifies it, sends it to the next signal tower. Like this, it goes from signal tower to signal tower to signal tower to signal tower until it gets to the receiver. But it happened so fast. For me to explain itself, it took 30 seconds. But as soon as you speak, the other person hears it. Everybody okay with it? But then sometimes, guys, let's say you're in a lift. The moment you get into lift, the voice starts breaking. It's not clear. The other person can't hear you. It's echoing. What happened? The moment you get into a lift, what happens? Physical obstacle, guys. A lift is built of what? A lift is built of thick metal, isn't it? Okay, it looks very nice from outside, but if you actually see the outside structure of a lift, it's just thick metal. Okay, so signals find it very difficult to get through that metal. Sometimes a tiny gap in the door only it gets through. That's why it doesn't go to 0, but it comes down to 1 bar. You get it? So the moment you get into a lift, these signals can't reach your phone. So the quality goes down a lot. That's how, the other person can't hear you. The line is breaking. There's a muffled noise, disturbance noise. It's echoing because the quality of the signal has dropped. Everybody okay with this? So everybody, signal towers use what signals? Signal towers use microwave. Signal towers, these signal towers you see on the road and in mountains and top of tall apartments and all that, they all use microwaves. Okay, what was the characteristic about microwave? They travel in a straight line, no? Point to point, like you said. Microwaves travel point to point. Now, do you understand why these towers are so tall? So that they can directly face each other. You get it? Now, say for example, if somebody next door comes and puts a taller building, high chances Dialog will say, you know what, we want to cancel our agreement here. And they will start talking to that building. You get it? Because that building now becomes a major obstacle for these antennas. You get it? Okay, so guys, signal towers, now you know why signal towers are so tall. And you now know what type of signals they are using. What signals are they using? They are using microwaves. So guys, since they are using microwaves, what do you think about their bandwidth? High or low? Their bandwidth is extremely high. Their frequency is higher now, and the frequency goes up, bandwidth also goes up. So microwaves are transmitting data at a very high bandwidth. But remember, signal towers need to be directly facing each other. Any obstacle in between and communication will not happen. So think about this. At home, your router, is it using microwaves? The router in your house, the Wi-Fi router in your house, do you think it's using microwaves? No way, right? Your router is surrounded by obstacles, isn't it? There's no way a signal tower can get to your router. So then what is your router using? We're going to talk about it now. Okay, so quick question here. Signal towers communicate with signal towers using microwaves. Signal towers talk to signal towers using microwaves. Signal tower to your router, there's a different wave. Because microwaves can't penetrate this building and come to your router. No chance. Okay, this building is too big for it. Okay, so a different wave is used for signal tower to router. We'll see what that signal is. Okay, right. Everybody, can you all read this? This last paragraph, can everyone read? neighboring cell towers are positioned so that there is a direct line of sight between them. Are we all okay with this? Neighboring cell towers are positioned so that there is a direct line of sight between them. Okay. Right. Then guys, we move on to the next one, which we call radio waves. Now, what do you all know about radio waves? It has a bigger wavelength, longer wavelength than microwaves. What about its frequency though? Its frequency will be lower. When frequency is lower, what about its speed? Speed also goes down. The number of instructions it can carry will also go down. Okay, when the wavelength gets bigger, frequency goes down. When frequency goes down, number of instructions, all that go down. Can you guys read radio waves? Radio waves are also electromagnetic waves that are used to create a wireless connection between technologies. Awesome. Radio waves are omnidirectional. Microwaves were uni. They can only travel in one direction. Radio waves, omni. They can go all over the place. Keep reading it. Radio waves are lower in frequency than microwaves. However, the wavelength is big. According to the diagram I showed you, what did I say? As big as the size of a building, right? These are massive waves. They are normally used to transmit data over both short and long distances, and they can pass through solid objects. Like what? Like walls, like glass doors, not metal elevators and things like that, but doors and glasses and all, they can get through. Okay. So wireless local area networks, the networks you use at home, are using what? Radio waves. Everybody okay with this? This router here is also using radio waves. Speed is not that great. If you compare the router speed with your signal tower speed, massive difference. But it's enough for us. We can manage with it. Okay. Radio waves can be sent from devices such as, what is WAP? Wireless access point. So wireless access points also emit radio waves to other devices within range. These devices could be in different rooms in a building, as radio waves can travel through walls. Everybody okay with it? Radio waves, they are the size of a building. No, they can get through walls. Okay. So even if you're inside your hotel room or you're inside a classroom or you're in your bedroom, it doesn't matter. Signals will get to you. But guys, remember, the quality will reduce every time it comes across an obstacle. You all okay with that now? The radio waves, even though they can get through physical obstacles, every time they have to get through a physical obstacle, quality will keep reducing. Are we all okay with this? Okay, that's obvious. Okay. Then number 3, guys, shall we have a look at light waves? Boys, girls, shall we have a look at light? So here we are talking about something called infrared light. Okay. Infrared light. Can everyone know about infrared light, isn't it? I saw a video on YouTube that told me guys, this remote and this projector are communicating using infrared. Now tell me, what do you know about infrared? What about its wavelength? Boys, Hima, all of you all. Infrared's wavelength, what can you all tell me? Where is it? Infrared is over here. So infrared's wavelength is smaller than radio and smaller than microwave, but it has a higher frequency here. Okay. So everybody, a beam of infrared light is directed through the air from one device, from this remote to the projector. So there needs to be a direct line of sight. Understand that now? Okay. Both need to be directly facing each other, because infrared, it doesn't have a big wavelength. So sender and receiver need to be close and need to be directly facing each other as well. Okay. Now this light, somebody told me, guys online, I'm going to stop sharing my screen and enable my camera. I saw a video on YouTube that said the webcam doesn't have any filters. 1 minute, Richard. By using this, can we only connect a single computer by a single network adapter? Richard, I didn't understand you. You're referring to what? by using this means what I'm referring to. Everybody, I didn't try this at home, but let me see if it works now. So let's make my video bigger. Okay. Let's switch off the background also. They told me our smartphones camera has filters, so it doesn't show the infrared light. But they said webcams do not have those filters. So I want to just check and see. All right. I don't think Zoom's camera will also allow me. Let's see if I press a button. You guys saw that light? See if you all can see it now. You all can't see it now, right? You all cannot see it now. Now when I press it, guys, look here. I'll keep it at a distance. You all can still see it now. You online students can see it. These guys cannot see it. Okay? You all can't see it. Your eyes cannot see that light. But this camera can see that light. So now when I press it in front, where? There you are. That light appears. Okay? That's the infrared light. That is the infrared light. Okay? Okay, so everybody, let me go back and share my screen. Okay, I don't have much to tell about infrared except that we use it for remotes. Okay, right, can you guys keep reading it? Everyone, the last paragraph, infrared is sometimes used as an alternative way. Infrared is sometimes used as an alternative way to connect peripheral devices such as a keyboard and mouse. You all know about this. Okay. However, it is not a very popular method for connecting devices as an infrared signal is quite weak and requires a direct line of sight between the peripheral and the computer. Okay, so infrared waves is also available. You can use it to transmit data, but it's not the best. Number one, direct line of sight. Number two, very small range. Okay, so it's not the best. We would prefer you use radio waves. Okay. Right, everybody, guys, girls, can we come down to our last one, satellite? Boys, girls, everyone, let's come down to satellite. Guys, all of you all know about button phones, no? We call them mobile phones. In Sri Lanka only, we say button phone. What's the difference between a button phone and a smartphone? Major difference is what? The buttons. Good. The smartphone also has buttons. Volume buttons are there. The touch screen is a major difference. Also, internet access, right? A smartphone can access the internet. Button phones normally, not all, normally cannot access the internet. Now, guys, have you seen in these, I'm talking about these 2,000, 3,000 rupee button phones, even those phones, once you put a SIM card, it can detect your location. Have you guys seen that? These simple button phones, even though you can't connect to the internet, when you put your SIM card, it will tell you you're in Kohuala, you're in Nugegoda. Exactly, it might not be able to tell you, but it can tell you where you are. Now, when you are connected to Wi-Fi or mobile data, it can tell you exactly where you're located. Everybody okay with this? So, guys, detecting of your location is done using a technology called GPS. What does GPS stand for? Global Positioning System. Everybody okay with this? Detecting of your location is done using GPS, Global Positioning System. Global Positioning System works by talking to a satellite. It talks to a satellite and figures out where you are. Everybody okay with this? Can you all read paragraph number, the last paragraph here? Everybody read this last paragraph below. A process called, no. One before last paragraph. The one before last paragraph, can you all read? The most common use of satellite communication is in GPS. If a person has a portable device like a mobile phone, they will normally be in the line of at least 10 satellites at any time. Okay, I'm going to show you all this. A process called triangulation can be used to find a user. This is where at least 3 satellites are used to pinpoint where you are. Okay, so guys, can you all check this? This is what we call triangulation. So these are satellites. I'll talk about this later. Everyone look here. So for example, you are located here, we'll say below. your SIM card will send a signal to many close by satellites that can then pinpoint exactly where you are located. Pinpoint is not the best word. It can figure out, it can detect where you're located. Okay, if you're connected to Wi-Fi or mobile data, then yes, pinpointing is okay. Otherwise, it will just figure out or detect where you are located. Are we good? So everybody think about this. In your phone, you don't have a SIM card. You don't have a SIM card. Can you make any phone calls? Think nicely and tell me. You can make one phone call, which is emergency. You can make an emergency phone call, right? You can call SOS numbers, emergency numbers you can call. How is it happening? No SIM card even now. Your phone is going to connect to a satellite. That satellite will handle the communication for you. So guys, how do you think about the quality of the call? Do you think the person will be loud and clear? No. The quality of the call will be, it will be like a policeman's walkie-talkie sound quality. Very difficult to understand what they're saying. But in an emergency situation, at least the person who's responding to your call can see your location and they can respond immediately. Are we all okay with this? Okay, right. Now shall we read satellite, everybody? A satellite is an artificial body that is sent into space to orbit the Earth. Orbit the Earth. So you guys can't see it, but it's out there orbiting the Earth. This is what it looks like. Everybody, this is what a satellite looks like. Okay, can you all see what are these side parts for? These side areas are solar panels, which means the satellite is working. Does the satellite ever shut down, power down? No. Where is it receiving its power from? From the sun. It's solar powered. Okay, and since it's solar powered, the sun is always there now. So it's working 24/7. Okay, so everybody look at this. So this is a satellite tracker 3D. And I'll zoom out because when I zoom in, it becomes difficult to show. So these are the many satellites that I'm zooming out that are orbiting our Earth. Okay, how many has Sri Lanka put on? Anyone know how many Sri Lanka has? Don't remember? We have one called Ravana, right? We recently in 2015 or 16 we put out one. We released one. You can't say put out. The what do you call? What's that university called? Michael C. Clark. No, Professor Arthur C. Clarke. What's that university called? Moratuwa. I can't remember. I'm sorry when my geography is really bad. But we have released, Sri Lanka has released 2 satellites into orbit. One is with a Chinese company, I remember. Okay. And there are 2. One is called Ravana or something. And the second one, I can't remember the name. We have 2 satellites orbiting. Okay. So these are the satellites you have. Okay. And the majority of satellites, if I'm not mistaken, are owned by Starlink. Starlink is now putting out so many satellites. So that's how they are able to provide you with unlimited internet access. Okay. And yeah. Okay. Can you guys read satellites now? Satellites transmit data using radio waves. Do you know why? Why are satellites using radio waves? Exactly, they are orbiting the Earth, right? From the satellite to your destination, so many obstacles in between. Is it clear? The distance is also massive. So you can't use microwaves, you have to use radio waves. So satellites communicate with something called a ground station. Everybody okay with this? A ground station looks something like this. Everyone saw this? This is what you call a ground station. So signals are sent from here to the satellite using these ground stations, and from the satellite to Earth using these ground stations. Okay? Right, keep reading it, guys. The radio waves can travel through each layer of Earth's atmosphere to the satellite. Okay, the satellite can also transmit radio waves to the ground station on Earth. I'll give you guys a very simple example. Everybody, your phone call quality versus the walkie-talkie quality here. What do you think? Well, I've heard the policeman's walkie-talkie, right? That quality versus your phone call quality. Which one has a better quality here? Your phone call, right? Can I say a much better quality? Your phone call quality, the phone call you make on Dialog, SLT, Mobitel and all that, its quality is much better than the policeman's walkie-talkie, right? Agree? Now guys, when you make a phone call, signals are going from where to where? Signal tower to signal tower to signal tower to signal tower. In each signal tower, what's happening to your signals? Strengthened, amplified. That's why when it comes to your phone, quality is pretty much good. But in a walkie-talkie, what's happening? In a walkie-talkie, what's happening? Have you seen the policeman playing with the antenna always? They adjust the antenna, they turn it this way, that way. Isn't it? What's happening? Signals are coming from the satellite. So imagine from satellite to this walkie-talkie, distance is massive. Lots of interferences in between. So by the time it comes at walkie-talkie, how is the quality? Quite bad. You can barely understand what's being said. Everybody okay with this? I'll give you all one more example. You have, you all know the local TV antenna? Everybody, the local TV antenna, you guys can buy and install it for your TV. And normally we put it on our roof. Dialog TV antenna, what happens? Do you buy it and do you install it? No, Dialog TV comes and installs it themselves. They'll send somebody to install it for you. Isn't it? And have you all seen the Dialog TV antenna? It's like a dish, right? And they put it at a certain angle only. And how is the quality difference in terms of reception? Your local TV antenna reception, pretty bad, right? Lots of disturbance in it. You know why? Because your local TV antenna, everybody, when I say local TV antenna, what am I talking about? You all have, if you all have TV at home, you all have an antenna like this, right? TV antenna. You already have put it on the roof or in the balcony or, you know, somewhere outside. You all have an antenna like this, right? I'm not talking about this. I'm talking about this. These antennas are communicating with whom? These antennas are communicating with the satellite. That's why by the time the signal comes to your TV, it has traveled a long distance. It has gone through so many electromagnetic interferences. Is it clear? So by the time it comes to your television, the quality is quite poor. That's why when you view it, Sirasa and Rupa Vahini and all, it's not very good. But Dialog, what are they doing? Signals are going from where to where? Signal tower to signal tower to signal tower to signal tower, and then it comes to your antenna. Everybody okay with this? When you use this Dialog TV antenna, they position the antenna to face the closest signal tower. Is it clear? So signals are coming from a signal tower, which is a lot closer than signals coming from a satellite. Which is why cable TV, Dialog TV, POTV, whatever you call it, their quality reception is so good compared to you using an ordinary antenna. Now, when you use an ordinary antenna, do you need to pay any monthly fee? When you use this normal TV antenna, do you need to pay a monthly fee? No, it's free. It's a part of the government service. But when you use this, they charge you a monthly fee because they have to maintain those signal towers. Everybody okay with this? Sounds good? This is what we call satellite communication. Is it becoming popular in today's world? Very much because of recently who came into the Sri Lankan market? Because of Starlink, by communicating with a satellite. Everyone, you have seen the Starlink antenna, right? Starlink setup cost is what, 120,000 or something like that, right? It's the cost of that antenna. Starlink antenna here. A device like this, they come and fix it on your roof. Okay, just like this, they fix it on your roof. This is talking to a satellite. Guys, girls, everybody, I hope that's making sense to you all. Okay, can you guys read that one for last paragraph? I already read it, right? Okay, right then, guys, we have now come to the end of part 1. Next, we need to start part 2. Those who haven't taken part 2, please take it from front. Okay, right, guys, we'll take a break. Then we'll be back at. Right, everybody, guys, girls, all of y'all, we are back. Let's continue with part. We are going to start part 3 now. Okay, we are going to start part 3, and part 3 is your. Where is it? Guys, online, you all need to get part 3, right? So. Not part 3, and part 2. I'm sorry, part 2, not part 3. Everybody, part 2. I have to give you all part 2. My bad, part 2. Right, so everybody, we have now seen what a network is. We have seen the components that make up a network. We have then spoken about implementing a network. Okay, you can use wired or wireless. Okay, now let's see what do we have next. Okay, so everybody, guys, girls, when you all come down to page number 4, we are going to be talking about network models. Okay, different ways of connecting your network. Okay, in terms of network by size, what do you all remember? I didn't explicitly teach it to you all, but do you all know networks by size? A really small network around one user, you would call it. Like, for example, your smartphone and your smartwatch are connected. What would you call it? PAN. PAN stands for Personal Area Network. Then a network that's accessible within one location, like a building. LAN, Local Area Network. Then a network that can be accessed across the world. Wide Area Network. We call it Wide Area Network. Right. Now we are going to look at the connectivity. How are these devices connected? Okay. So can you all read this first paragraph over here? You have learned about the different ways the data can be transmitted. It can be wired, wireless, okay? But you also need to know the different kinds of structure a network can have, okay? So let's see what are the 4 structures we have. We have something called client to server. We have something called peer to peer. We have something called ad hoc and something called tethering, okay? Let's start with the easiest one, something called client to server. In a client to server, you have a server and you have clients. Okay, so everyone look at this diagram here. You have a very powerful computer that's controlling this network, and everybody who is connected to this powerful computer is known as, or are referred to as, clients. These are all your clients and they are all connected to what we call a server, a very powerful computer. All right, can you guys keep reading it? A server is a computer that is a point of control in the network. It serves the client. So the client creates requests and the server fulfills those requests. Are we okay? Right. Everyone, I want you to think of an example. Think about Uber Eats. On Uber Eats, when you open up the app, guys, and we'll say your internet connection is working, you are connected. You are connecting to a client to server network. Agree? When you connect to Uber Eats, you're connecting to a server computer. Okay? And that particular server computer is basically in control of the entire network. Say, for example, they want to block you from accessing the network. From the server, can they block you? They can very much block you from the server itself, right? From the server itself, they can block your account. Okay, that's what we mean by the server controls the entire network. Think about Instagram. Instagram is a client to server network, your smartphone being the client and Instagram being the server. Okay, if that server goes down, you can't access Instagram. Are we all good? Okay, right. Can you guys see the different types of servers we have? We have something called a file server, a server computer that's responsible for storing user files. Okay, like for example, think about Dropbox, think about iCloud, think about Google Drive, think about OneDrive. These will be file servers. Then we have something called web servers, server computers that contain the website information of a website. Okay, when you access pizzahut.com, you're accessing a web server. When you access ikman.lk, you're accessing a web server. Okay, and then we have something called print server. These are server computers that handle print requests. Now, for many of you, I might wonder, why do we need a server computer just to handle printouts? But I want all of you to think of an organization like a bank. In a bank, every document is a confidential document, isn't it? In a bank, you can't allow employees to print whatever they want because there's a lot of confidential data over there. So in a bank, any printout any employee wants to take, he has to send it to a server. That server will then ask his supervisor or whoever to approve it. Once the supervisor or manager or whatever approves it, then the printout is taken. And the server will record who initiated it, who approved it, what time was it taken, when was it taken, all those details are recorded. Is it clear? So chances of confidential data being printed are minimized. Are we all okay with this? Now, are these the only servers? There are many other servers as well. We have another one known as application server. Okay, we have another one known as authentication server. Server computer is responsible only for checking your username and password. Okay, so there are a variety of servers. Okay, right. So everyone, can you read that last sentence also over there? Each client computer that is connected to the network sends requests to the servers in the network for data or services. So guys, tell me, what service or request do you send Uber Eats? When you get on to Uber Eats, what are the requests that Uber Eats is fulfilling for you? You just said that its server computer fulfills a request now. So what request is Uber Eats fulfilling for you? I didn't get you. Hunger. How is it fulfilling your hunger? Go in order. Hunger is the end product now. Before that, who shows you the menu? Who gives you the menus? Uber Eats server sends you the menus, isn't it? Then guys, you choose your items, you add it to a cart, and then Uber Eats server computer will provide you with a payment gateway for you to enter your payment details. Is it clear? After that, the Uber Eats server computer will connect you with a restaurant. Then Uber Eats server computer will then connect your order with a delivery driver. Isn't it? Okay, so this is the service that they are providing. This is the request. So you put a request. I want to find restaurants. It then immediately asks you what your location. You give your location. Is it clear? Then based on your location, it starts displaying restaurants that you can access. Everyone okay with this? That's the request that they are fulfilling for you. Instagram also same. When you get onto Instagram, they don't show you all the posts on Instagram. No, they show you posts of people that you are following only. Is it clear? And then their algorithm will also show you posts that you're actually interested in. You get it? That's the request that they are fulfilling. When you open Instagram, you're basically saying, show me content. It then decides what content to show you. Everyone okay with this? Right. Can you guys look at the next type of network? Oh, sorry. Can you guys come down to benefits? Benefits of client to server. Number one, we have centralized management. No need to read it even. The name tells you. Centralized management means what? Exactly. The server manages the whole network. Is it clear? Guys, if you have violated laws on Instagram, okay, let's say, for example, you have been creating fake profiles and causing a lot of problems on Instagram. Do they need to physically come and visit you and take your phone away? Instagram doesn't need to do any of that. What does Instagram do? From their server, they block you out. Isn't it? Think about Uber. You have a pending payment on Uber. Do they come physically to collect the payment? No, they just block your account, or they will not allow you to put another ride until you make that payment. Isn't it? This is what you call centralized management. The server manages the whole network. Number two, who provides security here? The server manages security as well. Encryption, user accounts, passwords, access rights. Okay, now when you get onto Instagram, you can only see your messages. You can't see other people's messages, right? When you get onto Uber Eats, you can only view the prices. You can't change prices. Isn't it? The server computer has put access rights where you can view prices, but you can't change prices. A hotel owner can view and change prices of only his hotel, not the other hotels. Everyone okay with this? So that's what you call data security. Data security is managed by the server. Data backup. Guys, just because you lose your smartphone, does it mean Instagram account is gone? No, just because you lose your smartphone, does it mean your Uber Eats account is gone, lost? No, right? Data backup means what? The data is not stored on your device. The data is stored on the server. So even if you lose your device, no problem. You can still access it on from another device. You get it? All your Instagram data, your Uber Eats data, your emails, all that are stored on servers. So even if you change your device or you lose your device or your device fails, not a problem. You can again access a server from another device. That is what we call data backup. The server will see and make copies of your data. Okay. Then scalability. You can connect as many clients as you want to a server. You can access your email account from as many devices as you want. Are we good? And another benefit is what? Resource sharing. The server can share many resources with you. Okay, maps and menus and prices and payment gateways, and they're given printers and all that. Various resources the server can share with you. Are we good, guys, girls, everyone? Can you all keep 3 benefits of client server network in your mind, please? 3 benefits of your client to server network. Everyone, can you keep in mind, please? Boys, all of you all, can we go through this? Then if there are benefits, there are definitely going to be some drawbacks as well. There's going to be some problems as well with it. Okay, let's see what these drawbacks are. Drawback number 1, expensive, very high setup cost. You're going to have to buy these servers. It's not going to be cheap. Then guys, your server fails, your whole network fails. Okay, if the server fails, and we have seen these problems happening. Okay, we have heard of Facebook going down, we have heard of Meta going down, we have heard of Google going down, we have heard of WhatsApp going down. That's because their server failed. The need for skilled management. Managing these servers means you need skilled employees to do it for you. Okay, not everyone and anyone can do it. What are performance bottlenecks? Everyone know what's a bottleneck? Everyone know the neck of a bottle, no? Isn't it? So all of y'all think about this classroom. In this classroom, when I tell all of y'all, okay, class is over, y'all can go. Up to the door, everybody is moving really fast. At the door, what happens? The door can allow only one person go out, right? So everybody comes and gets stuck over there. So over here, we're all moving smoothly. At the door, it's a bottleneck. We all slow down over there. Okay, things really slow down at the door. So on a server also, we have the same problem. What is it? Sometimes a server is busy dealing with too many users. The users can access the server, but to process the user's request can take time because it has a lot of users to deal with. Everybody okay with it? You can connect to booking.com, but the moment you run a query, I want to know hotels in Anuradhapura, things get very, very slow. Because right now there are so many users using booking.com. Everyone okay with this? Sometimes bottlenecks, performance issues can come up with a server. A good example I can give you all. Election night. Election night, everybody is busy accessing what? If we had the presidential election tonight, everybody will be watching. Not TV. TV also. News First, Hero News, Daily Mirror. These sites will be very, very slow. Why are they slow? Because a lot of traffic on these servers. Is it clear? It will say connecting to Daily Mirror, but loading. You have to wait. Okay, that's what they call a bottleneck. Okay, the server is having too many users or too many clients to deal with. Can everyone go through it? Drawbacks of client to server, and can you all have 3 in mind, please? Okay, Akash, all of you come on, go through it. Drawbacks. I'm going to stop at this point and do some past paper questions with you all. Okay, right. Can everyone come back to networks part 1? Everybody come back to networks part 1 below. Networks part 1. Question number 2, everybody. A network may be connected by a hub, a router, or a switch. Identify the statement that only applies to a switch. They have made the word only also bold, so be careful. So what do you think over here? A device that connects parts of a network together. Does only a switch do that? No, a hub also can do that. A router can also do that. A device that accepts data from one computer and sends it to another. Can all 3 do that? All 3 can, no? All 3 can do that, right? You don't have a tute with you. You have a tute with you. You read it at home and came. Okay. Everybody, all 3 can do this. Number 3, a device that accepts data on multiple input ports. Data comes in from many ports and sends it to the correct output port. That sounds like a switch, isn't it? Why didn't you all take router? It doesn't have ports. You want to say it has ports, no? A router has ports. This is exactly okay. So over here you can't take router. So here the best answer seems to be C. The best answer. What's wrong with D? A device that reads the IP address. I'm going to stop there itself. Why? Because switchers. We are interested in switchers now. We are interested in switchers. Switchers, do they deal with IP addresses? No, they deal with MAC address. Right. Mikhail connects his laptop to the local area network. He uses media access control addressing to prevent unauthorized mobile devices connecting to the local area network. Where is the laptop's MAC address held? In the, what does NIC stand for? In the network, in the device, in the network interface card. In the network interface card. All right, our last one. The table shows situations involving the use of a network. Complete the table to give the type of connectivity, medium and signal for each situation. Some cells have been completed for you. So guys, girls, all of y'all, computers and printers in a school share the same servers. What do you think the connectivity would be? There are only two possible connectivities now, wired or wireless. So for this scenario, what do you think? Wired sounds suitable, right? You can go with wired. What type of, so it's electrical signal. What type of cable do you think we would be using here? They have asked medium. It's electrical, they have mentioned. So what cables, I shouldn't have, what mediums support electrical signals? Twisted pair, coaxial, power line. But in terms of a school, coaxial you can't know, because printers don't support the coaxial cable. So you are left with power line and twisted pair. Which one is more common? Twisted pair is a lot more common. So you can go with twisted pair cable. A laptop communicates with a wireless access point. What will your connectivity be? You will immediately say wireless over here. Wireless. The signal type will be? Your signal type will be? What are the signals you all know of? In the electromagnetic spectrum, I told you all so many signals now. Radio, microwave, infrared, light. From these four, which one is most suitable? We're talking about a wireless access point, something inside a building. It has to be radio waves, no? It has to be radio waves. So radio waves, medium is what? No, medium. The radio waves are carried using yeah, isn't it? Radio waves are carried. It's yeah, isn't it? Radio waves are yeah, or you can say space. Okay. Yeah is used to or electromagnetic signals, even if you want, you can say it. Electromagnetic signals. I think marking scheme says yeah, isn't it? Check the marking scheme thereafter. I think they say yeah. I'll just put slash yeah. Two towns. We're talking about two towns on either side of the Atlantic Ocean are connected. Definitely wired. The signal would be fiber. No, the signal will be light. No, the signal will be light, and the medium will be fiber optic cable. Only fiber optic cable supports light. No, so here you will say fiber optic cable. An artificial satellite beams signals to receiving dishes mounted on houses. Connectivity type will definitely be wireless, no problem there. Your signal type will be satellite, no? Microwaves is signal towers. Satellite is way too far for microwaves. It will be radio waves. It would be radio waves, and the medium would be again, yeah. Appliances in the home are connected to each other. They have already mentioned power line. So your connectivity will be wired. Your what do you call, signal type will be electrical. Guys, 1 minute. I want to do some previous questions. Can we have a look at topic? 1 second, please. I'll tell you all. Topic 1, part 1, page number 28. Can you look? Topic 1, part 1, page number 28. 2 questions from there. Question number 10 and question number 11. Topic 1, part 1. Okay. Question 10, please. Simple one. A smartphone is an example of technological convergence. In the early 2000s, mobile phones were given extra features such as they could text message. Since then, they have been developed to perform other tasks that previously could only be done using a personal computer, like a desktop. Give 2 tasks apart from text messaging that a smartphone can be used for that previously could only be done using a PC. Gaming. What else? Gaming is a valid answer. Next. Video conferencing, shall I say? Video conferencing. Give me one more. Earlier you couldn't do it on a mobile phone, but now you can. Calling. Calling was always there on a mobile phone. No. You said coding. Coding. Yeah, you can say coding. I had like calling. That's why I was surprised. Something else? Video editing. Browsing, surfing the internet. Okay. I'll say coding. Okay. All 3 of these you could only do it on a PC, like a desktop computer or a laptop, but now you can do these on your smartphone as well. The TV contains an embedded system. Identify the statement that best describes an embedded system. An embedded system must contain flash memory. I never taught you all a rule like that, right? It must, it can, but there's nothing must. An embedded system is controlled by an external control unit. Not always. Sometimes it might be. An embedded system is designed to perform a small number of specific functions. That sounds good. Look at D. An embedded system must remain powered at all times. That I didn't teach you all, right? I mean, there is no rule that they should always be on. So the best answer over here would go as answer C. Part 2 we can't do right now. Okay, question 13 and then I'm wrapping it up for today. Our last one. Okay, Rahma, all of you, Rahma, I'm sending my number here. Drop me a message, get added to the class group, and remind me to send you the tutes. Okay, message me on WhatsApp. Tell me you're in full-time AS. Desktop PCs use something called firmware during the startup process. Identify the item that must be present in the firmware for a PC to be able to start. Question 13, page 29. What should be there? In firmware, you need a video driver? No. You need operating system? You need, but what is more important than operating system? You need your bootloader. Your bootloader only says what hardware and software to be loaded. State the type of memory used in firmware. ROM or ROM is correct. What is the other option? You can also mention flash memory, right? Even flash memory can be used to store your firmware. Okay, so you can mention ROM or you can mention flash memory. Guys, already remember what is flash memory, right? So not flash memory means firmware. Firmware is instructions that are built into a hardware device like BIOS, drivers, date and time settings. Okay, right, all of you. Guys, there's a small change. Tomorrow you all will not have your exam. Okay, for next week. Okay, sorry about that. The paper has some issues. I couldn't change it yet. So everybody, next tomorrow I'll not keep your exam. I'll keep your exam the week thereafter. But still practicals happen. Please bring your laptop. Practicals are still happening. Bring your laptop and come. It's just that exam won't happen tomorrow. Okay. Right.